Hello dear aspirant, this is Infinite and I am Jamrudi. It will be my second class on inverse trigonometric function and this class is purely problem solving, okay? So if there is any issue throughout my classes, must comment on comment section, and if you feel to give any suggestion, definitely suggest me, okay? So it shall definitely motivate me, okay? So motivation is very important to do the good job, okay? So hopeful you all will be huge benefited if you follow my classes, okay? Let's see question number 1. The value of x for each. The value of x for which cos inverse cos 4 greater than 3x square minus 4x is. Options are that is 0, 2 plus root over 6 pi minus 8 by 3 b 2 minus 6 pi minus 8 by 3 comma 0 minus 2 and last option is 2 minus 6 pi minus 8 by 3 comma 2 plus 6 pi minus 8 divided by 3, okay? So based on the given information we must proceed further, okay? So let's see how to solve the problem. As we know, cos inverse cos 4 is equal to cos inverse cos 2 pi minus 4. Why? This can be written as this, okay? It is as it is basics of inverse trigonometric functions. I shall not go through this, okay? So it is 2 pi minus 4. Suppose this is in equation 1, so it definitely would be like this: 3x square minus 4x less than 2 pi minus 4. So it would be like minus 2 pi minus 4 less than 0. It is a quadratic expression, so as it is not factorizable, so mean we shall find out the value of x using Sridhar Acharya's rule, that is minus b plus minus root over b square, that is 16 plus 4ac mean 12 twice pi minus 4 by twice it is 2 into 3, so it is 4 plus minus 16 minus 48, 16 minus 48 mean 32 minus 32 12 2, that is 24 pi by 6. So 4 plus minus, as 4 is common here, so 4 6 are 24, it will be 6 pi minus 4 8 are 32 by 6. So after cancellation we shall get 2 plus minus 6 pi minus 8 divided by 3, okay? So its max value is, that is 2 plus this by this, and mean value is 2 minus this by this. If an equation is like this, that is x square less than s square, then its value would be, that is range of x would be like this, okay? So the least value of x would be, that is which is minimum, and max is which is maximum. As that is max value of x is this, that is 2 plus this, and mean value is 2 minus this, so its range would be option D, okay? Let's see question number 2. Sin inverse x plus sin inverse y plus sin inverse z is equal to 3 pi by 2. If then the value of x to the power 100 plus y to the power 100 plus z to the power 100 minus 9 by x to the power 101, y to the power 101, z to the power 101. Options are 0, 1, 2 and 3. Okay, so solution would be, as we know, the range of sin inverse x is minus pi by 2 to plus pi by 2. So its max value is pi by 2. It will be only possible when each function is pi by 2. Okay, so sin inverse x is equal to pi by 2 mean x is equal to 1, likewise y equal to 1, z is equal to 1. So if we put the value of x with z, then it is 3 minus 9 by 3, so it is 0. So option A would be the appropriate answer. Okay, question number 2 is also solved. Question number 3, the value of f for which the value of a for which ax square plus sin inverse x square minus twice x plus 2 plus cos inverse x square minus twice x plus 2 equal to 0 has a real solution. Real solution is options are, that is minus 2 by pi, b 2 by pi, c minus pi by 2, and d is pi by 2. Okay, so solution would be like this. As we know, sin inverse x plus cos inverse x equal to pi by 2, but a constraint is given on this condition, which is that is x should be in this range. So that is sin inverse this plus sin cos inverse this would be pi by 2 when x square minus twice x plus 2 in the range. So it suggests that x square minus 2x plus 3 greater than or is equal to 0 and x square minus 2x plus 2 mean plus 1 less or is equal to 0. So if we simplify it, then it would be like this, greater than or is equal to 0, and it would be x minus 1 whole square is equal to 0. Okay, so x minus 1 whole square plus 2 is always that is greater than or is equal to 0. Okay, it is not solvable. Do you know why? As it is one sided. Okay, if x is, that is the value of x is the 1, then it would be 2. If it is 2, then it would be, that is 3. So likewise, if we take the larger value of x, then this portion would become larger. Okay, so it is not solvable. So it would be rejected, and as it is less or is equal to 0 and it is a perfect square, so it cannot be less than 0, so it would be 0. So x is equal to 1. So x equal to 1 must satisfy this, okay? So if it is 1, into 1 plus pi by 2 is equal to 0, is equal to mean minus pi by 2. Okay, such kind of options is given here, which is option C. So it would be the appropriate option. Okay. Let's see question number 4. The trigonometric equation, the trigonometric metric equation sine inverse x is equal to 2 sine inverse n has solution for if minus 1 by root 2 lesser is equal to n lesser is equal to 1 by root 2, and if f belongs to R, C is more than less than half, and D is more than greater than or is equal to 1 by root 2. Okay, so let's think how to do. As we know, sine inverse x is within the range. So as sine inverse x is equal to this, that is 2 sine inverse n. So we must replace sine inverse x by 2 sine inverse n. 2 sine inverse n. So it would be minus pi by 4 less or is equal to sine inverse n less or is equal to pi by 4. It must imply n less or is equal to root 1 by 2, but it would be greater than or is equal to minus 1 by root 2. So option A is the appropriate option. Okay. Question number 4 is finished. Let's see question number 5. The sum of infinite terms, the sum of infinite terms, cot inverse 3 plus cot inverse 7 plus cot inverse 13 plus dot dot is. Options are pi by 2, B cot inverse 2, C tan inverse 2, and the last one is none of this. Okay, so to realize the problem, we need to focus on the given portion and it must suggest how to do. Okay, let's see is there any sequence or not. Okay, as these numbers are 3, 7 and 13, 3 can be written as 1 plus 1 square. Okay, likewise 7 is equal to 1 plus 2 square. Okay, and 13 is equal to 1 plus 3 square. So its general term, that is the suffix r, can be written as, if we convert cot inverse into tan, then it will be tan inverse 1 by 1 plus r square, and it is tan inverse r plus 1 minus r by 1 plus r plus 1 into r. Okay, so as it is like tan inverse a minus tan inverse b by 1 plus a into b, so its simplest form would be tan inverse r plus 1 minus tan inverse r. Okay, so its first term would be, that is, it can be written as the suffix 1 and it would be tan inverse 1 plus 2, sorry, 1 plus 1, that is 2 minus tan inverse 1. Second term would be tan inverse 3 minus tan inverse 2. The term, that is the suffix 3, tan inverse, it is 4 minus tan inverse 3. Okay, so dot dot, likewise there shall be many terms, and suppose the last term is the suffix, that is last term is rth term and its value is tan inverse r plus 1 minus tan inverse r. Okay, look on this sincerely, then okay, it these two terms will be cancelled, likewise this and this, and these, and there shall be another term which will be cancelled. Okay, so as it is rth term, its previous term will be the suffix r minus 1, and so therefore there shall be a term which will be cancelled by this term. Okay, so there mean after addition we shall get, that is, as suffix r would be the suffix r plus 1 minus the suffix, sorry, tan inverse r plus 1 minus tan inverse 1. Okay, so if we apply the role of inverse trigonometric function, that is, it is r plus 1 minus 1 by 1 plus r plus 1, so these two will be cancelled. Okay, so its final value is tan inverse r by 1 2 plus r. Okay, as we are asked to find the sum of the infinite terms, then r would be, that is, a large number. If a large number is divided by hugely large number, then it would be undefined. So tan inverse, a suffix, that is infinite, tan inverse is, it would be like this, so its value is pi by 2. As it is matched with option A, so appropriate answer will be option A. Okay, so last question of this session will be, let's see what is question number 6. The sum of the infinite terms of the series, the sum of the infinite terms of the series tan inverse 2 by 1 minus 1 square plus 1 to the power 4 plus tan inverse 4 by 1 minus 2 square plus 2 to the power 4 plus dot dot. Okay, and options are is pi by 4, pi by 2, c 3 pi by 4, and the last one is none of these. Okay, let's see how to do. That is, focus on the sum. sincerely, then you would be able to find a sequence between each term, and it is look like this solution. This suffix "ard", which is supposed to be the general term of this series, is tan inverse twice r by 1 plus r square, sorry, r to the power 4 minus r square. Okay, if r is 1, look, if r is 1, it is tan inverse 2 by 1 plus 1 to the power 4 minus 1 square. Okay, so it is first term. If r is 2, then it is second term. So its general term, that is rth term, would be this. So finally it can be written as 1 plus r square minus r into r square plus r, as it is twice r. So we must, that is, replace it by this using approved sign between them. Okay, so it would be like this, mean r square minus r. Okay, so the sum is balanced. Tan inverse r square plus r minus tan inverse r square minus r. So its first term will be the suffix 1 is equal to tan inverse 1 square plus 1 minus tan inverse 1 square minus 1. Second term is the suffix 2 tan inverse 2 square plus 2 minus tan inverse, that is 2 square minus 2. That term, suppose it is tan inverse 3 square plus 3 minus tan inverse 3 square minus 3. Suppose there are many terms and these are expressed as dotted sign. Okay, and it is the suffix r. If we sum up all of them, then it would be a suffix r. Okay, it is tan inverse 2. 1 square plus 1 is equal to 2. 2 square minus 2 is 2. This should be cancelled. Okay, 2 square plus 2 is 6. 3 square minus 2 is also 6. These two would be cancelled. Likewise, that is, all terms will be cancelled except these and this. Okay, this means that is tan inverse r square plus r minus tan inverse 0. Only these two terms will be left here. Okay, mean rest of all terms will be cancelled. Okay, so as we are asked to find the sum of infinite terms, so r is huge large. So if r is huge large, that is, it would be a suffix infinite. So it is tan inverse this minus 0, means tan inverse e. The value of tan inverse this is equal to pi by 2. So its ultimate value is pi by 2. Hopeful this session will be huge benefited for all of you, and you enjoyed my all this session. Okay, so this is the main this will be the, that is, over of this session, and I would urge all of you, if there is any suggestion, must suggest me and keep motivating me. It mean without motivation it is very hard to do good work. So this session is over here, and hopeful you are studying nicely. Okay, so bye bye for this session.